Welcome back to Galaxy Guru, where we're unraveling the universe's most mind-bending secrets, one galaxy at a time. You've stepped into a cosmic mystery that's closer to home than you might think. My name is Gino, and today we're diving into the galaxy we call home, the Milky Way. But here's the twist. How well do we really know it? Imagine living in a city so vast, you've only seen a fraction of it. That's our reality in the Milky Way. We're about to explore its hidden corners, starting with its spiral arms, some of which have been hiding in plain sight. Let's start with a simple question. What is the Milky Way? Most of us know it as that faint, glowing band of light stretching across the night sky, visible on clear, dark nights. But that's just the tip of the iceberg. The Milky Way is a barred, spiral galaxy, a vast, swirling disk of stars, gas, and dust, stretching over 100,000 light-years across. It's home to billions of stars, including our Sun, and it's part of an even larger cosmic neighborhood called the Local Group. But here's the thing. Despite being our home, much of the Milky Way remains a mystery. Why? Because we're inside it. Imagine trying to map a forest while standing in the middle of it. You can see the trees around you, but the full picture is obscured by the foliage. That's our challenge with the Milky Way. Interstellar dust and gas block our view, hiding entire regions of the galaxy from our telescopes. And yet, through centuries of observation and cutting-edge technology, we've pieced together a rough map of its structure. At its heart lies a supermassive black hole, Sagittarius A star, surrounded by a dense bulge of stars. Radiating out from this center are the galaxy's most striking features, its spiral arms. These spiral arms are like the galaxy's highways packed with stars, nebulae, and star-forming regions. They're not solid structures, but rather waves of density that ripple through the galaxy, shaping its appearance and fueling its evolution. For years, astronomers believed the Milky Way had four major spiral arms: the Scutum Centaurus arm, the Carina Sagittarius arm, the Perseus arm, and the Norma arm. These arms twist and turn, wrapping around the galaxy like the tentacles of a cosmic octopus. But here's where it gets interesting. Recent discoveries suggest there's more to the story. Hidden arms, fainter, less prominent structures lurk in the shadows, obscured by dust or tucked away in hard-to-observe regions. These hidden arms could change everything we thought we knew about our galaxy's structure, its history, and even its future. So, why should we care about these hidden arms? For one, they hold clues to the Milky Way's past. How did our galaxy form? Did it grow through mergers with smaller galaxies? Or did it evolve in isolation? The answers might be written in the stars and gas of these elusive arms. Moreover, understanding the full structure of the Milky Way could help us map the distribution of dark matter, the invisible force that holds galaxies together. And let's not forget, the more we know about our home, the better we can understand the billions of other galaxies scattered across the universe. In the next part, we'll dive deeper into what spiral arms are and why they're the lifeblood of galaxies like ours. But for now, let this sink in. The Milky Way isn't just a pretty picture in the night sky. It's a living, breathing galaxy, full of secrets waiting to be uncovered. And some of its most intriguing mysteries are hidden in its spiral arms. Thanks for joining me on this cosmic journey. If the Milky Way's hidden arms have you hooked, smash that subscribe button and ring the bell for more. Now, let's keep moving ahead. Okay, so we introduced the Milky Way. our home galaxy. We teased these mysterious arms hidden in plain sight. Now, in part 2, we're cracking open the big questions. What are spiral arms? How do they work? And why should you care? Buckle up. This is going to be a stellar ride. What are spiral arms, anyway? Picture a spiral galaxy in your mind. Maybe you're imagining those iconic images from the Hubble Space Telescope. A bright core with elegant curving arms stretching out like a cosmic pinwheel. It's a beautiful sight, right? But here's the twist. Those spiral arms aren't what they seem. They're not solid, fixed structures like the arms of a starfish or the blades of a ceiling fan. Instead, they're more like waves, dynamic ripples moving through the galaxy, gathering up stars, gas, and dust as they go. Let's break that down with an analogy. Imagine you're on a highway during rush hour. Traffic starts to slow and cars bunch up in clumps. Traffic jams. The road itself doesn't move, but the density of cars shifts as they pass through those congested spots. Spiral arms are the galaxy's version of traffic jams. As stars and gas orbit the galactic center, they hit these denser regions, called density waves, and pile up temporarily. But unlike a highway jam that leaves you late for dinner, these cosmic jams are doing something incredible. They're shaping the galaxy itself. Why do spiral arms matter? So, why should we care about these swirling waves? Well, for starters, spiral arms are the galaxy's star-making machines. When gas and dust get squeezed together in these density waves, the pressure ramps up, kind of like squeezing a sponge until water drips out. In this case, the water is new stars. That compression triggers gravity to take over, collapsing clouds of gas into hot, dense cores that ignite into brilliant newborn stars. That's why spiral arms are often dotted with dazzling young stars and glowing nebulae. Think of them as the galaxy's maternity wards delivering fresh stellar babies into the universe. But it's not just about star birth. Spiral arms are also the galaxy's cosmic mixers. As they sweep through, they stir up the galaxy's ingredients: gas, dust, and heavier elements like carbon, oxygen, and iron. These elements were forged in the hearts of earlier stars that exploded as supernovae, scattering the guts across space. The spiral arms scoop up this stardust and spread it around, ensuring the galaxy stays rich with the raw materials for future stars and planets. Without this mixing, the galaxy might run out of steam, its star-forming days fading into a dull, stagnant twilight. The variety of arms: major, minor, and hidden. Now, here's where it gets juicy. Not all spiral arms are created equal. Some are major arms, big, bold, and bursting with stars like the main arteries of the galaxy. Others are minor arms, thinner, subtler, harder to spot, like quiet side streets. And then there are the hidden arms, elusive, shadowy structures shrouded in dust or lurking in regions we can't easily see. These hidden arms might be the unsung heroes of the Milky Way, holding secrets about its past and present that we're only beginning to unravel. Have you ever wondered what kinds of stars live in these arms? In the major arms, you'll find the galaxy's rock stars, massive, bright, blue giants that burn hot and fast, living for just a few million years before exploding in spectacular supernovae. Minor arms, meanwhile, might host older, quieter stars, red dwarfs and sun-like stars that hum along for billions of years. The hidden arms? Well, that's the mystery we're chasing in this video. What treasures or surprises might they hold? How do spiral arms form? Okay, so how do these arms even get started? It all comes down to a cosmic dance between gravity and rotation. Picture the galaxy as a spinning disk of dough. If you drop a pebble or a cosmic disturbance into that dough, ripples form and spread. In a galaxy, those disturbances might come from a nearby galaxy, tugging on it, a burst of star formation, or even the galaxy's own central bar of stars. Over millions of years, these ripples grow and stabilize into the spiral patterns we see today. In the Milky Way, that central bar plays a big role. Our galaxy is a barred spiral, meaning it has a rectangular slab of stars at its core that acts like a cosmic engine. The bar's gravity pulls and pushes gas and stars, feeding the spiral arms and keeping them spinning. It's a bit like a DJ spinning tracks. The bar sets the beat and the arms dance to it. But not all the arms are grooving in plain sight. Some are hiding behind curtains of dust, waiting for us to pull back the veil. What's next for the Milky Way? So, where does this leave us with our own galaxy? The Milky Way's spiral arms aren't fully mapped out yet. Astronomers have identified 4 major arms, or so they think, based on stars, gas, and radio waves piercing through the dust. But those hidden arms we keep teasing, they could rewrite the story. Are there more arms than we realize? Do they stretch farther than we thought? And what do they tell us about where our solar system fits in this grand galactic puzzle? That's what we'll dig into in part 3. We'll explore what we think we know about the Milky Way's arms, how astronomers track them, and why those hidden arms might be the key to unlocking the galaxy's deepest secrets. Trust me, you won't want to miss it. The cosmos is full of surprises, and we're just getting started. Thanks for tagging along on this galactic adventure. If spiral arms have you spinning with curiosity, hit that subscribe button and ring the bell. So far, we have explored what spiral arms are and why they're the lifeblood of galaxies like ours. Now, it's time for us to dive into what we think we know about the Milky Way's spiral arms. Spoiler alert, it's not as straightforward as you might expect. So, how do you map a galaxy when you're stuck inside it? Let's find out. Let's start with a challenge. Imagine you're in a vast, sprawling city, one so big, you've never seen it all. You've got a rough map, but it's incomplete, with entire neighborhoods hidden behind skyscrapers or shrouded in fog. That's pretty much our situation with the Milky Way. We're not just visitors here, we live in it, tucked away in a quiet corner of one of its spiral arms. But mapping the galaxy from the inside? That's like trying to sketch a forest while blindfolded. We can see the trees around us, but the full picture, it's obscured by distance, dust, and the sheer scale of it all. So, what do we know? For decades, astronomers have pieced together a rough map of the Milky Way's spiral arms. The consensus? Our galaxy has 4 major spiral arms, each one a swirling river of stars, gas, and dust, stretching out from the galactic center like the arms of a cosmic octopus. These arms are the Scutum Centaurus arm, the Carina Sagittarius arm, the Perseus arm, the Norma arm. These names might sound like something out of a sci-fi novel, but they're real, and they're the backbone of our galaxy's structure. Let's take a quick tour. The 4 major arms, a galactic tour. Think of the Milky Way as a bustling city, with the galactic center as its downtown core, a dense, chaotic hub of activity, home to the supermassive black hole Sagittarius A. Radiating out from this core are the spiral arms, like highways connecting the city's neighborhoods. The Scutum Centaurus arm. This is one of the 2 arms closest to the galactic center. It's a major star-forming region, packed with young, bright stars and glowing nebulae. If the Milky Way were a city, this arm would be the industrial district, busy, vibrant, and full of energy. The Carina Sagittarius arm. This arm is home to some of the galaxy's most famous landmarks like the Eagle Nebula and the Lagoon Nebula. It's a bit like the city's cultural quarter, dotted with dazzling sights and cosmic wonders. The Perseus arm. Located farther out, this arm is quieter but still bustling with star formation. It's the suburban sprawl of the galaxy, spacious with pockets of activity. The Norma arm, the most distant of the major arms, Norma is like the city's outskirts, less explored but full of potential for new discoveries. But here's the thing. These arms aren't static. They're constantly shifting, evolving, and interacting with each other as the galaxy spins. And mapping them? That's no easy task. The challenge of mapping from the inside. So, how do astronomers even begin to map a galaxy when they're stuck inside it? It's not like we can hop in a spaceship and zoom out for a bird's eye view. Instead, we have to rely on clever tricks and cutting-edge technology to peer through the fog of interstellar dust and gas that blocks our view. One of the biggest hurdles is interstellar dust. This cosmic haze scatters and absorbs light, making it nearly impossible to see distant stars with optical telescopes. It's like trying to see through a thick fog. Only the closest objects are visible, while the rest disappear into the mist. To get around this, astronomers use radio waves and infrared light, which can penetrate the dust and reveal what's hiding behind it. For example, radio telescopes can detect the faint glow of neutral hydrogen gas, which traces the spiral arms like a cosmic highlighter. By mapping where this gas is densest, we can sketch out the arms' locations. Infrared telescopes, like the Spitzer Space Telescope, can peer through the dust to count stars and measure their distances, giving us another layer of the map. But even with these tools, it's tricky. The Milky Way is a three-dimensional puzzle, and we're trying to solve it from a single vantage point: Earth. It's like trying to map a mountain range while standing in the middle of it. We can see the peaks around us, but the full range? That's a different story. The Gaia mission. A game changer. Enter the Gaia mission, a space telescope launched by the European Space Agency in 2013. Gaia is like the galaxy's census taker, meticulously measuring the positions, distances, and motions of over 1 billion stars. It's given us the most detailed 3D map of the Milky Way ever created, and it's revolutionizing our understanding of the spiral arms. Thanks to Gaia, we've confirmed the locations of the 4 major arms and even spotted hints of smaller, fainter structures. But here's the kicker. Gaia's data also suggests that our map might not be complete. There could be more to the Milky Way's spiral structure than we've realized, hidden arms or extensions of the known ones lurking just out of sight. Are there more arms than we think? For years, astronomers debated whether the Milky Way has 2, 4, or even more spiral arms. The current model says 4, but recent studies suggest there might be minor arms or spurs branching off the major ones. These smaller arms are like side streets in a city, less prominent but still important for understanding the full layout. In fact, some research points to a 5th arm or even a fragmented structure where arms break and reconnect in unexpected ways. It's like discovering a hidden alleyway in your neighborhood, one that changes how you see the whole area. So, what does this mean for our understanding of the Milky Way? It means our map is still a work in progress. The 4 major arms are the backbone, but the full picture might be more complex, with hidden arms waiting to be uncovered. And those hidden arms, they could hold clues to the galaxy's past, how it formed, how it's evolved, and maybe even how it will change in the future. In the next part, we'll dive into the mystery of these hidden arms. What are they? Why are they so hard to detect? And what secrets might they reveal about our cosmic home? Stay tuned to Galaxy Guru as we continue our journey through the stars. Thanks for joining me on this cosmic adventure. If the Milky Way's spiral arms have you hooked, smash that subscribe button and ring the bell for more. Okay, so far we have mapped out the 4 major spiral arms that form the backbone of our galaxy. But now, we're diving into a mystery. Not all of the Milky Way's arms are easy to spot. Some are hidden, lurking in the shadows. We'll uncover why these spiral arms stay out of sight and what they might mean for our understanding of the galaxy. Let's dive in. Picture this. You're standing in a bustling city, gazing down a grand avenue lined with towering skyscrapers. That's what the Milky Way's major spiral arms are like. Big, bright, and impossible to miss. But what about the side streets, the narrow alleys winding through the shadows? Those are the hidden arms, and they're playing a cosmic game of hide and seek with us. So, why can't we see them all? Let's break it down. So far, we charted the 4 major arms: the Scutum Centaurus arm, the Carina Sagittarius arm, the Perseus arm, and the Noma arm. These are the galaxy's heavy hitters, packed with stars, gas, and cosmic action. But astronomers suspect there's more: smaller, fainter arms, or extensions that we haven't fully pinned down. These hidden arms are out there, but the galaxy itself is throwing up roadblocks to keep them under wraps. Why are some arms hidden? So, what's hiding these cosmic treasures? The first big obstacle is interstellar dust. Think of it like a foggy morning in a dense forest. Everything beyond a few trees vanishes into the mist. Interstellar dust is made of tiny particles, carbon, silicon, bits of stardust, that scatter and soak up light, especially the visible kind we rely on with our eyes and basic telescopes. It's the galaxy's natural smokescreen, cloaking distant arms in a hazy shroud. But dust isn't the only hurdle. There's also distance. The Milky Way stretches over 100,000 light years across, and we're stuck on one side, nestled in the Orion arm, a minor spur between 2 major arms. Trying to spot the far side of the galaxy is like peering across a vast ocean to spot a flickering lighthouse. The farther the arm, the dimmer it gets, and dust only makes it worse. And then there's faintness. Not all spiral arms are created equal. Some are less dense, fewer stars, less gas, quieter neighborhoods. Compared to the dazzling major arms, these hidden ones are like ghost towns, whispering their presence instead of shouting it. Together, dust, distance, and faintness turn these arms into galactic phantoms. What makes hidden arms different? Now let's get curious. What are these hidden arms? Are they just mini versions of the big ones, or something else entirely? Some might be minor arms, slender threads branching off the main highways, like tributaries flowing from a river. Others could be spurs or feathers, delicate structures linking the major arms or filling the gaps between them. And don't forget the far side arms, tucked away on the opposite side of the galaxy, where dust and distance team up to keep them out of reach. Here's where it gets wild. These hidden arms might not just be smaller, they could be different. Imagine an arm with fewer blazing young stars and more ancient dim ones, telling a quieter story of the galaxy's past. Or maybe they're fragmented, splitting and reconnecting in ways the major arms don't. It's like finding a secret maze beneath a city. Suddenly, the whole map looks new. Why do hidden arms matter? Okay, but why should we care? The major arms are already bursting with action, stars being born, supernovas lighting up the sky. Do these hidden arms really change the game? Oh, they do. Think of the Milky Way as a giant cosmic puzzle. Every piece, every arm, big or small, helps us see the full picture. These hidden arms could unlock secrets about how our galaxy formed, how it's evolving, and where it's headed. Take dark matter, for example. That invisible stuff holding the galaxy together? Hidden arms might clue us in on where it's hiding. By tracking how stars and gas move in these faint regions, we can map dark matter's influence, like feeling the breeze to trace an unseen wind. And then there's star formation. Are these arms fading relics of the past, or new structures just getting started? The answers could rewrite the Milky Way's biography. The quest continues. So, are we doomed to guess about these hidden arms forever? Not a chance. We're already closing in. The Gaia mission, mapping over 1 billion stars in 3D, is spotting hints of fainter structures between the big arms. And on the ground, radio telescopes, like the Very Large Array, are cutting through the dust with radio waves, tracing the galaxy's gas where visible light fails. Each discovery pulls us closer to the truth, but every answer sparks new questions. Could there be a fifth major arm we've overlooked? Do these hidden arms connect in ways we can't yet see? And what do they say about our place in the cosmic neighborhood? That's what keeps this adventure alive, and it's where we're headed next. Coming up, we'll uncover the tools and tricks astronomers use to pierce the Milky Way's veil, from radio waves to infrared magic. Stay with Galaxy Guru as we chase the galaxy's deepest secrets. In Part 4, we explored why some of the Milky Way's spiral arms stay hidden in the shadows, obscured by dust, distance, and faintness. Next up, we're diving into the tools and tricks astronomers use to pierce that veil and reveal what's lurking beyond. Spoiler: it's not just about bigger telescopes. Let's dive in. Part 5. Tools of the Trade. How we peek behind the Milky Way's veil. Let's start with the question: how do you see something that's hidden behind a wall of dust? If you're thinking X-ray vision, you're not far off. Astronomers don't have superpowers, but they do have some pretty incredible tools that let them see through the Milky Way's murky veil. These tools are the key to unlocking the galaxy's hidden arms, and they are as varied as they are ingenious. So, what's in the astronomer's toolkit? Let's break it down. Radio astronomy, the dust busters. First up, radio astronomy. Remember how dust blocks visible light? Well, radio waves laugh in the face of dust. They sail right through it, like a ghost passing through walls. By tuning into radio frequencies, astronomers can detect the faint glow of neutral hydrogen gas, the most abundant element in the universe. This gas traces the spiral arms like a cosmic highlighter, revealing their structure even when stars are hidden. It's like using night vision goggles to spot a path through a dark forest. One of the most famous tools in radio astronomy is the Very Large Array, VLA, in New Mexico. Picture a field of giant white dishes, each the size of a house, all pointed at the sky. These dishes work together like a massive ear, listening for the whispers of hydrogen gas across the galaxy. By mapping where this gas is densest, astronomers can sketch out the spiral arms, even the hidden ones. It's not a perfect picture, but it's a start. But radio waves aren't just for gas. They can also pick up signals from pulsars, spinning neutron stars that act like cosmic lighthouses. By timing their pulses, we can measure distances across the galaxy, helping to pinpoint where the arms are. It's like using sonar to map an underwater cave. Infrared astronomy, seeing through the haze. Next up, infrared astronomy. If radio waves are the ghost, infrared is the heat seeker. Infrared light has longer wavelengths than visible light, so it can slip through dust clouds like a cat burglar through a laser grid. This lets us see stars and structures that are otherwise hidden. The Spitzer Space Telescope, launched in 2003, was a game changer here. It floated above Earth's atmosphere, peering into the galaxy's dusty regions with its infrared eyes. Spitzer's images revealed stars and nebulae in the hidden arms, like lifting a foggy curtain to see a bustling city street. It's not perfect. Some dust still blocks even infrared, but it's a huge leap forward. And let's not forget Gaia, the European Space Agency's star mapping mission. Gaia doesn't use infrared for dust penetration, but it does something equally amazing. It measures the positions, distances, and motions of over 1 billion stars with jaw-dropping precision. By tracking how stars move, we can infer the galaxy's structure, including its spiral arms. It's like watching a flock of birds to map the wind currents they ride. The power of multi-wavelength astronomy. Here's the secret sauce: multi-wavelength astronomy. By combining data from radio, infrared, visible light, and even X-rays, astronomers can build a layered map of the Milky Way. Each wavelength reveals a different piece of the puzzle. Radio waves show us the gas. Infrared reveals the stars behind the dust. Visible light highlights the bright, nearby stars. X-rays point to high-energy events like black holes or supernovae. It's like assembling a jigsaw puzzle where each piece comes from a different box. When you put them all together, the hidden arms start to take shape. The hidden arms revealed. So, what have these tools uncovered? Thanks to radio and infrared observations, astronomers have spotted hints of minor arms and spurs, smaller structures branching off the major arms or filling the spaces between them. For example, the Orion arm, where our solar system lives, is actually a spur, not a full-fledged arm. It's like a side street off a main highway. But there's more. Recent studies suggest there might be far-side arms on the opposite side of the galaxy, hidden not just by dust, but by the sheer distance. These arms are like the galaxy's back alleys, hard to reach, but potentially full of surprises. And here's a wild card. Some research points to fragmented arms, where the spiral structure breaks and reconnects in unexpected ways. Imagine a river splitting into smaller streams, only to merge again downstream. These fragmented arms could be clues to the galaxy's chaotic past, collisions with smaller galaxies or bursts of star formation that reshaped its structure. The quest for clarity. Despite these advances, mapping the hidden arms is still a work in progress. The Milky Way is a tricky beast. Its dust is thick, its arms are tangled, and we're stuck on one side. But every new tool, every new observation brings us closer to the truth. And the stakes are high. Understanding the full structure of the Milky Way could help us answer big questions. How did our galaxy form? How does it compare to others? And what's its future? In the next part, we'll dive into the discoveries these tools have enabled. What have we found in the hidden arms? And what secrets do they hold about our cosmic home? Thanks for joining me on this starry adventure. If the tools of astronomy have you hooked, smash that subscribe button and ring the bell for more. In part 5, we explored the ingenious tools astronomers use to peek behind the galaxy's dusty veil, from radio waves to infrared magic. Now, we're finally pulling back the curtain to reveal what's been hiding all along: the Milky Way's hidden arms. What are they? How were they found? And what secrets do they hold about our cosmic home? Let's dive in. Let's start with a quick recap. In the last episode, we learned how astronomers use radio telescopes, infrared observatories, and star mapping missions, like Gaia, to cut through the dust and map the Milky Way's spiral arms. We've known about the 4 major arms for decades: the Scutum Centaurus arm, the Carina Sagittarius arm, the Perseus arm, and the Norma arm. These are the galaxy's main highways, bustling with stars, gas, and cosmic drama. But here's the thing: those aren't the only arms out there. Hidden in the shadows, tucked away in the galaxy's back alleys, are smaller, fainter structures that have been playing hide-and-seek with us for centuries. And now, thanks to cutting-edge tech, we're finally starting to see them. So, what exactly are these hidden arms? They're not the galaxy's A-listers, but they're just as important. Some are minor arms, slender, delicate threads of stars and gas that branch off the major arms, like side streets off a bustling avenue. Others are spurs or feathers, even smaller structures that weave between the main arms, connecting them in unexpected ways. And then, there are the far side arms, lurking on the opposite side of the galaxy, where distance and dust make them nearly invisible. These hidden arms are like the galaxy's secret passages, quiet, unassuming, but full of stories waiting to be told. Discovering the hidden arms, a cosmic treasure hunt. So, how did we find them? It's been a bit like a cosmic treasure hunt, with astronomers piecing together clues from different wavelengths of light. Let's take a closer look at some of the hidden arms we've uncovered so far. First up, the Orion arm. Wait a minute, isn't that where we live? Yep. Our solar system sits in the Orion arm, a minor structure sandwiched between 2 major arms, the Perseus arm and the Carina Sagittarius arm. For years, astronomers thought the Orion arm was just a small spur, a cosmic footnote. But recent data from the Gaia mission suggests it might be more significant than we thought, possibly a full-fledged arm in its own right. Imagine that. Our little corner of the galaxy might be more important than we realized. It's like finding out your quiet neighborhood is actually a hidden gem. But the Orion arm isn't the only hidden structure. Astronomers have also spotted hints of far-side arms on the opposite side of the galaxy. These arms are tough to study because they're so far away, tens of thousands of light years, and shrouded in dust. But by using radio telescopes to trace the galaxy's gas, we've caught glimpses of their presence. It's like hearing whispers from the other side of a mountain, faint but unmistakable. And here's where it gets wild. Some research suggests there might be fragmented arms or broken spirals in the Milky Way. These are arms that don't follow the neat, continuous curves we're used to seeing in other galaxies. Instead, they split, twist, or even reconnect in chaotic ways. Picture a river that's been dammed and diverted over time, its flow interrupted, but still carving its path. These fragmented arms could be scars from the galaxy's past, shaped by collisions with smaller galaxies, or bursts of star formation that reshaped its structure. What do the hidden arms look like? Now, you might be wondering, what do these hidden arms actually look like? Are they just smaller versions of the major arms or something different? The truth is, they're a mixed bag. Some hidden arms are faint and wispy, with fewer stars and less gas, ghostly echoes of their brighter siblings. Others might be packed with ancient stars, glowing softly, like embers from a long ago fire. And some could be surprisingly active, with pockets of star formation lighting up the darkness. Take the Sagittarius arm, for example. It's one of the major arms, but parts of it are hidden from view by dust. When we peer through the haze with infrared telescopes, we find it's not just a single smooth curve. It's jagged, with spurs and feathers branching off like tributaries from a river. These hidden extensions could be where new stars are quietly being born, away from the spotlight. Or consider the outer arm, a faint extension of the Perseus arm that stretches into the galaxy's distant suburbs. It's so far out that it's barely detectable, but radio observations show it's there, wrapping around the galaxy like a distant halo. What's it like out there? Is it a barren wasteland or a hidden oasis of cosmic activity? We're still piecing that together. Why do these hidden arms matter? Okay, but why should we care about these faint, elusive arms? The major arms are already bursting with action. Stars being born, supernovas lighting up the sky. Do these hidden arms really change the game? Absolutely. Think of the Milky Way as a giant cosmic puzzle. Every piece, every arm, big or small, helps us see the full picture. These hidden arms could unlock secrets about how our galaxy formed, how it's evolving, and where it's headed. For one, they might hold clues to the galaxy's formation history. Did the Milky Way grow by merging with smaller galaxies, leaving behind these fragmented arms as cosmic scars? Or did it form more peacefully, with its arms gradually taking shape over billions of years? The hidden arms could be the missing chapters in that story. They could also help us map the galaxy's dark matter, that invisible stuff holding everything together. By studying how stars and gas move in these faint arms, we can trace the gravitational pull of dark matter, like feeling the wind to map an unseen storm. And let's not forget star formation. Are these hidden arms dormant, or are they quietly churning out new stars? The answer could reshape our understanding of how galaxies like ours sustain themselves over time. A galaxy full of surprises. Here's the thing, the Milky Way is full of surprises. Every time we think we've got it figured out, it throws us a curveball. Just a few years ago, astronomers discovered a new arm, or at least a significant extension of an existing one, using data from the Spitzer Space Telescope. This arm, dubbed the Far 3 kiloparsec arm, is located near the galaxy's center, hidden behind thick clouds of dust. It's a reminder that even in our own backyard, there's still so much to discover, and that's what makes this journey so exciting. The hidden arms aren't just faint lines on a map. They're invitations to explore, to question, to wonder. What if these arms hold the key to understanding the Milky Way's past? What if they're home to uncharted star systems, or even life? The possibilities are as vast as the galaxy itself. Next up, we'll explore what these hidden arms mean for our understanding of the Milky Way. How do they change the way we see our galaxy? And what might they tell us about its future? Stay tuned to Galaxy Guru as we chase the galaxy's deepest secrets. Thanks for joining me on this cosmic treasure hunt. If the Milky Way's hidden arms have you hooked, smash that subscribe button and ring the bell for more. Okay, my friends, Over the course of this documentary, we finally pulled back the curtain on the galaxy's hidden arms, revealing the faint, elusive structures that have been hiding in the shadows. Next, we're diving into what these discoveries mean for our understanding of the Milky Way. How do these hidden arms change everything? And what do they tell us about the galaxy's past, present, and future? Let's find out. Let's start with a simple truth. The Milky Way is more than just a pretty spiral in the night sky. It's a living, breathing galaxy, constantly evolving, and its spiral arms are the engine driving that change. For decades, we thought we had it figured out. 4 major arms, neatly arranged like the spokes of a wheel. But as we've seen, the reality is messier, more complex, and way more interesting. The hidden arms we've uncovered, those faint, fragmented or far-side structures, are forcing us to rethink everything. They're not just extra details, they're game changers. So, how exactly do these hidden arms rewrite the map of the Milky Way? Let's break it down, a more complex structure. First, they reveal that the Milky Way's structure is far more intricate than we imagined. Instead of 4 clean, continuous arms, we're dealing with a tangled web of major arms, minor arms, spurs, and feathers. It's like discovering that your city isn't just a grid of streets, but a maze of alleyways, tunnels, and hidden courtyards. This complexity tells us that the galaxy's history is richer and more chaotic than a simple spiral would suggest. For example, the Orion arm, where our solar system lives, was once thought to be a minor spur. But recent data suggests it might be a full-fledged arm, or at least a significant branch of the Perseus arm. If true, that means our cosmic address is more prestigious than we thought. Like finding out your quiet suburb is actually a bustling district. And then, there are the far side arms, lurking on the opposite side of the galaxy. These distant structures could be extensions of the known arms or entirely new features. Mapping them is like trying to chart the other side of a mountain range without crossing it. But every glimpse we get adds a new piece to the puzzle. Clues to the galaxy's past. But it's not just about the map, it's about the story behind it. These hidden arms are like scars on the galaxy's skin, telling tales of its wild past. How did they form? One leading theory is that they're the result of galactic collisions. Over billions of years, the Milky Way has likely merged with smaller galaxies, each one leaving its mark on the spiral structure. Those fragmented arms and spurs, they could be the remnants of these cosmic crashes, like ripples in a pond after a stone's been thrown. Take the Sagittarius dwarf galaxy, for instance. It's a small galaxy currently being torn apart by the Milky Way's gravity, its stars scattering across our sky. Some astronomers think its remnants could be woven into the hidden arms, adding to their complexity. It's a reminder that the Milky Way isn't a static painting. It's a living canvas, constantly being reshaped by the forces of the universe. Dark matter and the hidden arms. Here's where it gets even wilder. These hidden arms might hold clues to one of the universe's biggest mysteries: dark matter. We know dark matter is out there, holding the galaxy together with its invisible gravity. But where is it concentrated? How does it shape the spiral arms? By studying the motion of stars and gas in the hidden arms, astronomers can map the galaxy's gravitational field, including the parts we can't see. It's like feeling the wind to trace an unseen storm. If the hidden arms are moving in unexpected ways, it could point to pockets of dark matter we didn't know about. And that could help us understand what dark matter actually is: exotic particles, modified gravity, or something stranger? Star formation in the shadows. Let's not forget about star formation. The major arms are the galaxy's star-making powerhouses. But what about the hidden arms? Are they quiet, dormant structures, or are they secretly churning out new stars? The answer could reshape our understanding of how galaxies evolve. Some hidden arms might be fossil arms, relics from a time when the galaxy was younger and wilder, now faded and quiet. Others could be active, with pockets of gas collapsing into new stars, hidden from view by dust. If we can find these hidden nurseries, it could change our models of star formation across the galaxy, and maybe even reveal new places where life could emerge. A new map for a new era. So, what does all this mean for the Milky Way's map? It means we're in the middle of a cosmic renovation. The old map, with its 4 neat arms, is giving way to something messier, more dynamic, and infinitely more fascinating. It's like upgrading from a sketch on a napkin to a 3D hologram. And the best part? We're not done yet. With new tools like the James Webb Space Telescope and the Vera Rubin Observatory coming online, we're about to get an even clearer view of the hidden arms. These next-gen telescopes will peer deeper into the infrared, cut through more dust, and map the galaxy's structure with unprecedented detail. It's like going from a blurry photograph to a high-def movie. What's next for the Milky Way? Here's the big question. What does this mean for us? Well, for one, it reminds us that even our home galaxy is full of surprises. Every hidden arm we uncover is a chance to learn something new about where we live and where we fit in the grand cosmic puzzle. But it's also a reminder of how much we still don't know. The Milky Way is just one galaxy among billions. And if it's this complex, imagine what else is out there. Maybe there are galaxies with even wilder structures, hidden arms within hidden arms, or entirely new types of cosmic architecture. The universe is a big place, and we're just scratching the surface. Next, we'll wrap up our journey through the Milky Way's hidden arms and look to the future. What's next for astronomers chasing these cosmic mysteries? And what might the hidden arms tell us about the galaxy's fate? Stay tuned to Galaxy Guru as we chase the galaxy's deepest secrets. Thanks for joining me on this starry adventure. If the Milky Way's hidden arms have you hooked, smash that subscribe button and ring the bell for more. Throughout this video, we've explored the galaxy's spiral arms, from the well-known highways to the hidden back alleys. We've uncovered what they are, why they matter, and how astronomers are mapping them with cutting-edge tools. Now, my friends, we're wrapping up our journey with a look to the future. What's next for Milky Way explorers, and what might the hidden arms tell us about the galaxy's fate? Let's dive in. Part 8. The journey continues. What's next for Milky Way explorers? Let's start with a simple truth. The Milky Way is more than just a pretty spiral in the night sky. It's a living, breathing galaxy, constantly evolving. And its spiral arms, both seen and hidden, are the engine driving that change. Over the course of this documentary, we've peeled back the layers of our cosmic home, revealing a galaxy far more complex and mysterious than we ever imagined. But here's the thing, we're not done yet. The journey to understand the Milky Way is just beginning, and the hidden arms are only the start. So, what's next for astronomers chasing these cosmic mysteries? And what might the hidden arms tell us about the galaxy's past, present, and future? Let's explore. New tools, new discoveries. First, let's talk tech. The tools we've used so far, radio telescopes, infrared observatories, star mapping missions like Gaia have been game changers. But the next generation of telescopes is about to take things to a whole new level. Take the James Webb Space Telescope, JWST, for example. Launched in 2021, JWST is already revolutionizing our view of the universe with its infrared eyes. While it's mostly focused on distant galaxies, it's also giving us glimpses of the Milky Way's hidden regions, peering through dust clouds to reveal stars and structures we've never seen before. And then there's the Vera Rubin Observatory, set to come online in the mid-2020s. This beast of a telescope will survey the entire sky every few nights, mapping billions of stars and galaxies with unprecedented detail. For the Milky Way, that means a treasure trove of data on its spiral arms, both the known and the hidden. It's like upgrading from a hand-drawn map to a high-def 3D hologram. But it's not just about seeing more stars. These new tools will help us track how the galaxy's arms are moving, how they're evolving, and how they're interacting with each other. It's like watching a time-lapse of a city growing and changing over centuries. Unanswered questions. The hidden arms' secrets. So, what are the big questions these tools might help us answer? Let's start with the hidden arms themselves. What are they made of? Are they packed with ancient stars? Or are they quietly churning out new ones? Do they hold clues to the galaxy's formation? Perhaps remnants of smaller galaxies the Milky Way has swallowed over time? And what about dark matter? Could the hidden arms help us map its distribution, revealing where this invisible force is strongest? Here's another puzzle. How do the hidden arms affect the galaxy's overall structure? Are they stabilizing the spiral pattern? Or are they signs of chaos? Evidence that the Milky Way is still settling into its shape after billions of years. Some astronomers think the hidden arms might be transient structures coming and going like waves on a beach. Others believe they're permanent fixtures etched into the galaxy's fabric. The truth? We are still figuring it out. And let's not forget the biggest question of all. What does this mean for us? Our solar system sits in the Orion Arm, a minor structure between two major arms. But if the hidden arms are more significant than we thought, could that change our understanding of where we fit in the galactic neighborhood? It's like discovering your quiet street is actually part of a bustling district. Suddenly, you're not on the outskirts anymore. The Milky Way's future, a galactic crystal ball. Now let's gaze into the future. What might the hidden arms tell us about the Milky Way's destiny? Well, galaxies aren't static. They evolve, merge, and sometimes even die. In about 4 billion years, the Milky Way is set to collide with the Andromeda Galaxy, a cosmic smash-up that will reshape both galaxies into a single giant elliptical blob. But what role will the hidden arms play in that merger? Will they be swallowed up? Or will they help shape the new galaxy's structure? And here's a wild thought. Could the hidden arms be clues to the Milky Way's past mergers? Some astronomers think our galaxy has already gobbled up smaller galaxies, leaving behind these faint, fragmented arms as cosmic scars. If that's true, then studying the hidden arms could be like reading the galaxy's diary. Each entry, a tale of conquest and survival. The human element, why this matters. But let's bring it back to Earth for a moment. Why should you care about the Milky Way's hidden arms? Well, for one, it's a reminder that even in our own cosmic backyard, there's still so much to discover. The universe is full of surprises, and the more we learn, the more we realize how little we know. That's what makes science and life so exciting. Moreover, understanding the Milky Way helps us understand the billions of other galaxies out there. If our galaxy is more complex than we thought, imagine what else is hiding in the cosmos. Maybe there are galaxies with even wilder structures, hidden arms within hidden arms, or entirely new types of cosmic architecture. The possibilities are endless, and that's what keeps astronomers and viewers like you coming back for more. A call to curiosity. As we wrap up this video, let's take a moment to reflect. The Milky Way's hidden arms aren't just faint lines on a map. They're invitations to explore, to question, to wonder. They remind us that the universe is a place of mystery, and that even the most familiar things, like the galaxy we call home, can still surprise us. So, what's next for Milky Way explorers? The journey continues. With new telescopes, new data, and new questions, we're on the cusp of a golden age of galactic discovery. And you're part of it. By watching, sharing, and staying curious, you're helping to push the boundaries of what we know about the cosmos. Thank you for joining me on this stellar journey through the Milky Way's hidden arms. If this video has sparked your curiosity, smash that subscribe button and ring the bell for more cosmic adventures. The universe is vast, and we've only just begun to explore it. Until next time, keep your eyes on the stars and your mind wide open.